Welcome back to the GCSEMathsPro YouTube channel. In today's video, we'll be going through the November 2023 paper, which is Paper 2 Calculator for Edexcel. So make sure you've got your scientific calculator with you, not just the phone calculator. Make sure you have the one that you will be using in the exam if you can. And let's start with question 1. So we've got expand and simplify. 3 multiplied by 2y minus 5 plus 7 multiplied by y plus 2. So literally just going to expand it, so that means multiply. So 3 times 2y is obviously 6y. 3 times minus 5 is obviously minus 15. And then the next one we've got 7 times y is 7y. And 7 times 2 is 14. So that's the expand bit. Then you obviously need to simplify, collect the like terms. So we've got 6y plus 7y would give us 13y, and then minus 15 plus 14 is minus 1. So that's your answer for part A. Part B, it says factorise fully 6x squared plus 15x. So that's kind of the opposite thing, right? We're going to put the brackets back in. Now, in this case, we've got obviously x squared, but it's not a full, complete quadratic, is it? We don't have all three parts. We've only got the first two parts of the quadratic, so I need to actually factorise this into a single bracket. So I'm going to pull out a common factor on the outside, which in terms of numbers is 3, but also in terms of letters I could pull out an x. And then inside the bracket, to get back to 6x squared, I need 2x. And to get back to 15x, I need to multiply that by 5. Okay, so 3x times 2x, 3x times 5. Part C, we've got make g the subject of the formula, so basically just rearrange it to get g on its own. So first of all, we could take away 11 from both sides to move that across, and then divide by 3. So that would be our answer. G is f minus 11 all divided by 3. So that's question 1 for 6 marks. Question 2, Karen is organising a party for charity. She spends £100 on food, £120 on a hall, and £80 on a DJ. Karen sells 54 tickets for the party. Each ticket costs £7.50. So we need to work out the percentage profit Karen makes for the charity. So percentage profit has a formula. It's basically the same as percentage change, actually, just obviously in the context of profit. We need to know two values to start with. We need to know the cost, total cost, which is obviously these three things added together. And we need to know the revenue or the sales. How much money did she make from selling the tickets, which is obviously then this part. So total cost, this is calculated, so you can obviously either add it up yourself or put it in the calculator, but that should add up to £300. So that's our cost. And then the revenue or the sales is obviously 54 tickets multiplied by £7.50 each, which we can put in our calculator. £7.5 is £405. So that's the revenue or the sales, whatever you want to call it. That's how much money she got. So our formula for percentage change is the profit divided by the original cost. So the profit is the difference between these two, isn't it? How much it cost her and then how much she sold it for. The profit is the difference. So let's work that out. That would obviously give us £105. So 105, the profit is effectively the same as the difference. You know, when you do percentage change, you work out the difference, don't you? The change in actual money, or in whatever the context is. In this case, the difference is the profit, and then divide it by the original. Now, the original number is, if you think about a timeline, she would have had to pay for all of this before the actual event happened, right? Before she got the sales. So the original is always the cost. And to make it a percentage, obviously you want it times by 100. So if we bring back our calculator, we have 105 divided by 300 multiplied by 100 to make it a percentage, which is 35. And I feel like if you get 35 or a number like that, you think, yeah, that seems reasonable. It's not a load of random decimals. That seems like a reasonable answer, especially for obviously question 2. So question 3, Andrew invests $4,500 in a savings account for 2 years. The account pays compound interest at a rate of 3.4% per year. Calculate how much Andrew has in this savings account at the end of 2 years. So this is just a really straightforward compound interest question. I'm pretty sure you have it on your formula sheet, but if you've already memorized it, we need to take the initial amount or the principal amount, which is obviously the 4,500, multiply that by, in brackets, you do 1 plus the percentage as a decimal. So to convert it into a decimal, we obviously divide by 100. And then that bracket there, you do to the power of the time. So in this case, it's 2 years. You could also obviously just write it as 1.034. That's the exact same thing as what I've put in that bracket. If you've converted it yourself, that's fine. Exactly the same thing. So calculator, obviously, 4,500 multiplied by 1.034 squared. So not the 4,500 squared, just this last bit is squared. And then there we are, 4,811.20. I'm just rounding it to 2 decimal places. It hasn't really mentioned it, but because it's money, I've just thought put it to 2 decimal places. That's literally it. If they ask for the interest that he earned, you would have to do another step and you'd have to subtract the 4,500 original from this total. The total you get from that formula is the amount that's in the savings, including the initial amount. So just double check what the question is. Okay, question 4, we've got a nice solving linear equations question. So first of all, you can notice that we've got x on both sides, so I need to get those together. I'm going to move the x here to the left because overall I want to have a positive number of x's, so that makes more sense. I'm going to add x to both sides, so that makes it 6x. And then I'm also going to therefore move the 14 to the other side to get it away from the x. So also add 14 because it's currently a minus. And then you get 52 plus 14 is 66. And then obviously divide by 6. 11. That's literally it for that one, 3 marks. So question 5. Chris, Debbie and Errol share some money in the ratio 3 to 4 to 2. Debbie gets £120. So I tend to like to write this out again, just to get rid of all the words. So I put the initials in the correct order, obviously then match it up with the ratio. And then they've actually told us what Debbie gets. I'm going to put the 120 below Debbie's column. There we go. Chris then gives some money, some of his share to Debbie and some of his share to Errol. The money that Chris, Debbie and Errol have is now in the ratio 2:5:3. How much money did Chris give to Errol? So we have to obviously start with Debbie, right? Because that's the one that we have in terms of a ratio and in terms of physical money. So that's the only comparison we can make. So first of all, I would do 120 divided by 4 because that will tell me how much money I get per one part of the original ratio. So obviously that would give you £30. So that's £30 per part. So for example, we could then work out that Chris obviously gets 3 parts. So that would be 30 times 3, which is 90. And Errol gets 2 parts, which is 30 times 2, which is 60. So now we know exactly how much everyone had originally. Then looking at the change here. So they've now got a new ratio, but we've still got the same amount of money across all 3 people. Obviously they've just shifted the money around. So let's add up the total of this money just to see what we've got there. So we've got 90 plus 120 plus 60. So there was 270 in total. They've just shifted it around between them, haven't they? They haven't actually added or subtracted any money from the total. They've just moved it around between the people. So now we've got our new ratio. And so I'm going to share out that. So if we add up that, that would give us 10 parts. So you see how obviously 270 divided by 10 parts now tells me with the new ratio that we have £27 per part. So the actual question was, how much money did Chris give Errol? So we could just work out, either you could work out Chris's amount, the 2 parts, and subtract and find out the difference between what he originally had and what he has now, or you could work out Errol's amount and then see how much he's gained. It doesn't really matter. So 27, I'm going to work out Errol times 3 is £81. So do you see how Errol originally had 60 and now has 81? So the difference is obviously then 21, isn't it? That's how much he gained, and therefore that's how much Chris gave him. So that's what I would do for that one, £21. Now if we scroll down, we can see question 6 is bearings. So the bearing of port B from port A is 147 degrees. Work out the bearing of port A from port B. So this one is kind of hard because you haven't got a visual. So you can always draw one if you prefer, or you can try and just memorize the method, but I'll show you the visual that I would draw. So we have to know which way round this is. When it says the bearing of B from A, that's the key, from A. So if I were to draw, obviously draw a north line for each of them, let's say this is point A, we're measuring from A, so we're measuring from that north line clockwise, so in that case to the right. And then to B, so that would be 147, which is, I mean, it doesn't have to be accurate, but let's say that's just there, isn't it? Therefore, that's the north line for B. Obviously, draw a line between them. It can just be a quick sketch, you don't have to spend this much time on it. So the bearing of port B from A is this measurement here. That is 147, right, first of all. Then the bearing of A from port B, so from B, so we're starting at the north line of B, again clockwise. Do you see how that would be that bit? So what I can do is the north lines are obviously parallel because they're both pointing north. I could work out this bit here using angles on parallel lines, so that's interior angles, isn't it? So you would do 180 minus 47 to get that bit over there, which is 33. And then, because I think you'd naturally think that was just the answer if you didn't visualize it, but after that what you'd have to do is then obviously this is around a point, isn't it? So you'd have to do 360 minus that. So you could just memorize, if they ask me this question, I just need to do 180 minus the number they gave me, then 360 minus that number. You could do that. That's fine, you don't have to draw it. So we get 327. And that's already 3 digits, so I don't need to put a 0 or anything for the bearing. Okay, so 327 for question 6. Question 7. The diagram shows an empty tank in the shape of a cylinder. The cylinder has radius 15 centimeters and height 43 centimeters. And then they've said that water flows into the tank at a rate of 0.47 litres per minute. So calculate the number of minutes it will take to completely fill the tank. So to fill the tank, that means volume, doesn't it? So first of all, before I even worry about this litres per minute thing, I need to work out the volume of the cylinder. Now the volume of a cylinder, obviously it's a prism, so you work out the cross-sectional area, or in this case the area of this circle, and then you just multiply it by the height. So obviously the area of a circle is pi r squared times by height to make the volume. So in this case we've got 15 squared is the radius, well the radius is 15 and then you square it, multiplied by the height, which is 43, so obviously I'll put that into my calculator. So pi times 15, oh that's not pi, pi, there we go, times 15 squared times 43. I'm going to leave it just in terms of pi, I guess, at this point, just so we don't round it. So 9675 pi. Now, the only thing with that is that it's obviously in centimeters cubed, isn't it? That's the units here. They're given us centimeters, so volume is centimeters cubed. However, this bit is in liters. So you can either convert the 0.47 into centimeters cubed or convert the centimeters cubed into liters. It's up to you. I'm just going to convert this into liters. So you would obviously have to know that conversion. So there are, in 1 litre, 1000 centimeters cubed. So I'm going to convert this into liters by obviously just dividing by 1000, which I think will probably give me obviously a more complicated number. So divide by 1000, which if you've got it as a number is 30.394 ... You could leave it in pi if you want, it's up to you. ... liters. And then we can look at this rate here. So 0.47 litres per minute, how many minutes? So I'm just going to divide that answer. Obviously, I'm going to keep all the decimals in my calculator. I'm not going to round it. And divide it by 0.47. So literally take that answer button, 0.47. Okay, so that's 64.67 minutes. Now they've also then said correct to the nearest minutes. I'd obviously round it to 65. Okay, so even if you're not sure what to do with the litres bit, you could always just obviously start off by working out the volume. That's at least the first bit we could do. Question 8. So a number x is written correct to 2 significant figures. The result is 1.9. Complete the error interval for x. Obviously, I guess a mark for each of the numbers there and in their correct position. When you've got numbers rounded, so in this case they've rounded it to 2 significant figures, haven't they? Error intervals are the same as upper and lower bounds. Same concept if it's rounded, which it is in this case. Now, you probably figure it out straight away, but I'm just going to draw this just to show you, because sometimes I feel like significant figures can be kind of confusing compared to decimal places. So I always draw a number line like this, put the number in the middle. Whatever they rounded it to, I do 1 above, 1 below. So that is, what is one significant figure above? That would be 2.0, wouldn't it? And then 1 below, 1.8. And then obviously you'd go halfway. Now, you might have been fine to just figure that out yourself. That's absolutely fine without drawing this. But if there's one way you're just not so sure, if it's not as obvious, the rounding, then that's what I do. Whatever they've rounded it to, I do 1 above, 1 below. So let's say if they rounded it to the nearest 5, I would do 5 above, 5 below, and then obviously halfway. Okay, so you should get 1.85 is less than or equal to x, which is less than 1.95. Now you don't need to put 1.94999. I know that obviously technically 1.95 would round up to 2, technically, but that's why the inequality is written like this. It's not written equal to 1.95, it's just saying anything less than 1.95. Okay, so you don't need to put the whole 1.949 recurring. Don't need to worry about that. Okay, question 9, we've just got expanding triple brackets, so take the first 2, or whichever 2 you want to do first, but just take 2 at a time. So that's just double brackets, expand that as normal. X squared minus 2x plus 7x minus 14. Then simplify this, as in collect the like terms in the middle. So x squared plus 5x minus 14. And then bring back whichever one you haven't done, so that in this case is the third one. And now effectively do the same thing, but instead of having 4 of these lines, you're going to end up with 6, aren't you? What I mean by that is x squared by x is obviously x cubed. X squared by the second term in that other bracket, 3x squared, and then move on to the next one. So that's 5x times x, 5x squared, 5x times 3, 15x, and then move on to the last one. So minus 14x, minus 42. If you do it in that order, you don't have to necessarily do it in that order, but if you do it in that order, do you see how the like terms are then next to each other? So when you then simplify it, it's kind of easier, I feel like. So if I simplify that, you get obviously x cubed. These two added together is 8x squared. 15x minus 14x is just plus x, and then minus 42. Okay, that's expanding triple brackets. Okay, probability trees. So Shakir has to complete 2 tests. He can either pass or fail each test. The probability that he will pass the first test is 0.87, which they've written here. If he passes the first test, the probability he will pass the second test is 0.94, so that's there. If he fails the first test, the probability he will pass the second test is 0.73, so that's there. And obviously then complete the tree diagram. So I filled out those 2. Obviously then each of these kind of pairs of branches have to add up to 1. So that would be 0.13. This one would be 0.06. This one's 0.27. So that's 2 marks. Now we've got a part B. So part B, work out the probability that Shakir passes at least one of the tests. So we're going to highlight the options that satisfy that sentence. So he has to pass at least one. So he could pass the first one, fail the second one. He could fail the first one but then pass the second one. And there's actually one more option because of the word at least. At least. At least is obviously one of each, but also it could be both. He passes at least one, so he could actually pass just one, or he could pass both, couldn't he? So, pass, and pass is also an option. So here, to work out this probability, you've got 2 options. You can either, obviously if you have a look at our tree, do you see the only branches, the only option that's not highlighted is fail and fail. That's the only one that wouldn't come under passing at least one. So what you could do is work out the probability that he will fail both and then subtract it from 1, because obviously all probabilities add up to 1. You could do that. That's obviously a more direct way of doing it because otherwise you'd have to work out all 3. I'm just going to show you how to work out all 3 just so that it is a consistent method, but obviously it's more calculations, isn't it? So let me see if I can... Let me see if we can match the colours. So for the pink one, the probability that he will pass both, when you're working with probability trees, so it's saying pass and pass, it means multiply because it's the and rule. So if I pass the first one is 0.87, I pass the second is 0.94 multiplied. Grab the calculator obviously. Multiplied by 0.94 gives me 0.8178. That's the probability that he will pass both, okay? Then, next one, hopefully we can see this yellow. Pass and fail, so again, oh, that's too pale, isn't it? I'll do it in black and we can highlight it. 0.87 multiplied by 0.06 this time. So back to my calculator. Obviously that's a much smaller chance. 0.0522. Highlight that so you know it's the yellow one. That's the probability of the yellow one. And then the green one, fail and then pass, 0.13 multiplied by 0.73. .0949. Okay, that's the probability of all these 3 possible options. But only one of these 3 will happen in actual reality, won't it? He's not going to do both tests twice. There's only one of these colours of options that he will follow. So it's like saying either the pink option will happen, or the yellow option will happen, or the the green option will happen. Either pink, yellow, or green. Okay, not multiple. So that's the OR rule. And when we're using the OR rule in probability, it means add. So all you need to do at the end is add up those 3. So add that to 0.8178. Add that to 0. I missed a 0 there, didn't I? 0.522. Let me write in that other 0. So the total should be 0.9649. This was meant to have another 0 here. There, that's better. Okay. So this is always the same for probability trees. You multiply between the branches, and then if you end up with multiple options here, you then add them. Okay, question 11, we've obviously been given graphs here. So the graphs of y against x represent 4 different types of proportionality. Match each type of proportionality in the table to the correct graph. So effectively, I almost forget about the fact that it's proportion. Just imagine these are equal signs, and you're just trying to recognize graphs, basically. So just imagine it's like equal, 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 and so on. So the first one we're looking for, x squared, that's a quadratic. Just a basic quadratic. So obviously I know normal quadratics are a U-shape. We've not got a full U-shape here, but you can see that half of it in D. The reason why I know it's not B, because I know technically that could go up, is because I know that also it has to cross through 0, 0 if it's just y equals x squared. Because think about it. 0 squared is 0, isn't it, for y and x? So I know that that one is D, quadratic. The second one is just linear, as in a straight line. And the only straight line here is A. Again, there's no kind of plus C is there, so it's going through 0. And the third one is a reciprocal graph, which you should recognise is B. Now, the last one, the graph of the square root of x, that's not on the syllabus to learn, but because the other 3 are, you just effectively use process of elimination. It's obviously C. Okay, so that last one, you might not know what it is, but you should technically know the other 3. So obviously it's just the last one that's left, which is C. Okay, so ignoring proportion, it's literally just graphs. Question 12. A is the point with coordinates 7, 13. B is the point with coordinates -3, 21. C is the point with coordinates 15, 23. M is the midpoint of AB, and N is the midpoint of BC. Work out the distance between N and N into 1 decimal place. So when it's distance and it's kind of coordinates, it's normally Pythagoras. But we're going to need to know the coordinates of M and N in order to use Pythagoras. So you can sketch it out if you want. You don't necessarily have to. I need to know the coordinates of M and N. So that's just basically the midpoint of A and B and then B and C. So to find the midpoint, it's basically like an average. So the mean. So M would be, obviously you do X and Y separately. M is A and B. So looking at A and B, the average of X is 7 plus minus 3 over 2. That's how we find the average. And then Y would be 13 plus 21 over 2, which should give us 7 plus minus 3 is obviously 4 over 2 is 2. And then 13 plus 21 is 34 over 2 is 17. So that's M. And then N, midpoint again, that one's B and C, so -3 plus 15 for X over 2, and 21 plus 23, over 2 for y. So that one adds up to 12 over 2 is 6, and then that one adds up to 44 over 2 is 22. So now we've got the coordinates of m and n, which again, this bit, if you want to maybe sketch that out, you can obviously, if you want to ever visualize something, then you feel free to sketch it. So that's 2, 17, so let's say that's about here. M, and then n is 6 along, so a bit further along and a bit further up. So we want to work out this distance here, which you can obviously see is effectively, or what is a diagonal, but it's effectively a hypotenuse, isn't it? Because I can use the coordinates to work out the perpendicular lines, as in vertical and horizontal. So like, do you see how that creates a right angle triangle? So I know that this is at 2, this is at 6. You see how that horizontal side would be 4? And then I know up here would be, that was 17, wasn't it? And that was 22. So you see how that vertical side is 5. And then it's just Pythagoras, isn't it? So we're doing A, B, and C. Obviously, C is the side you're trying to, is the side of the hypotenuse, which in this case we're trying to find that one out. So that's handy. Pythagoras is A squared plus B squared equals C squared, which I'll put as mn squared. So put that in your calculator. 4 squared plus 5 squared, you probably work that out yourself to be fair, is 41. So obviously we need to square root it though, don't we? Square root of 41 is obviously root 41. I'll put it here, mn is therefore the root of 41. But they have said give your answer correct to 1 decimal place, so I don't want it as a third, so I'm going to use my SD button. 1 decimal place would be 6.4. And there's technically no units because we don't know if it's centimetres or what. 12, yeah. Sure we didn't miss any. Question 13. This is a really nice one if you just memorise what to do. It's a very similar method every time. So prove algebraically that 0.0723 recurring can be written as 241 over 3,330. So converting recurring decimals into fractions, we always say let x equal whatever decimal they've given you. Make sure you obviously write the decimal correctly as well. Then what we need is to isolate the bit of the decimal that's recurring. So see how the 0 is not recurring, it's just 723 that keeps repeating. So to move 0 out the way, I'm going to multiply by 10 on both sides. So that would obviously be 10x. And then do you see how that would be 0.723? So that's the bit that's recurring, and that's the bit I'm isolating in my decimal part. But we do need 2 versions of that. So the next time that this would recur, it has to recur in the exact same order as well, is if, see how that would be 723 again, 723, is if I multiply 1, 2, 3 by 1,000, that would be the next time that it would be recurring in the same order, wouldn't it? So I need to multiply both sides of my equation by 1,000, so 10 times 1,000 is obviously 10,000 x, and then this side would be 723, and then the decimal, so 0.723. See how that is the same exact decimal recurring? I can't have it in a different order because now I'm going to subtract the 2, take them away. So what we can do is oh, it's not going to let me do it. Okay. Obviously, I want to subtract them, you know, the other way around, but you can rewrite it if you like. So I'm going to do 10,000 take away 10. So that should give me 9,990x. And then do you see how on the other side, 723.723 recurring minus 0.723 recurring. See how that's going to cancel out the decimal. That's the whole point. We want to cancel out the decimal. So I end up with just 723 minus 0, which is just 723. Obviously, then I want to solve that for x, so we're going to divide across by the 9,000. Now I've got a fraction. Obviously this is calculated, so what you can do, you don't have to work this out yourself. What you can do is just type that in and hope that obviously it should simplify to the same thing they have. And you can see here, yeah, it does, doesn't it? It simplifies to the exact same thing. 241 over 3,330. And the reason why that's proven it is because we've said originally, we said let x equal to the decimal. And then we've at the end got x is also in this format of the fraction. So they must be the same thing. They must be both equal to each other. Okay, question 14. So we've got some proportion here, but by the looks of it, double proportion, 2 lots. So y is proportional to x squared. Obviously, we've got our matching pair, which is y is 3 when x is 0.5. And then separately to that, we've got x is inversely proportional to w. When x is 2, w is 0.2. So find the value of y when w is 2. We need to relate these together, basically. So first of all, just deal with them separately. So separately, I'm going to look at the first one. It's basically three steps. The first step is to write the equation. So you should have memorized for proportion, the equation for direct proportion, that one's direct, isn't it, is y is equal to kx. However, obviously you just sub in whatever makes sense in terms of your context. So this is actually x squared. So it'd be y is equal to k times x squared. That's direct proportion. Step 2 is obviously we need to work out what k is, so that's why they've given us a matching pair. So sub those in, 3 for y, k multiplied by 0.5 squared, which you can obviously look up or convert into a fraction, it's up to you. So that's a quarter, or in other words 0.25. So we've got a quarter k is equal to 3. So to solve that, obviously I'm going to divide by a quarter, or that's the same as timesing by 4, isn't it? So 3 divided by that is 12. So for this one, the k is 12. So if I rewrite my equation, I get y is equal to 12x squared. That's the relationship between y and x. Step 3 is then to sub in the values, but we're not actually at that point yet in terms of this one, because we've got 2 that we need to work through. So for the second one, exactly the same thing, but obviously this one is inverse proportion, isn't it? So it's not the same formula. The inverse proportion, I'll put it in terms of y and x, is y is equal to k over x. Okay, it's divided, it's reciprocal. In this case, obviously, we've got x and w. So you put them in the order that they are written. So x would go here, w would go here. Okay? Now, technically, because we had a k over here, it's obviously not the same k, so I'm going to use a different letter. But normally, if you've only got one, you use k. Let's use, I don't know, like c or something. The constant. We need to do the exact same thing now. Step 2, sub in the values they've given us. So 2 for x, and then 0.2 for w. And then solve it for that constant. Obviously, I'll multiply by 0.2, which is 0.4. 0.4, or maybe if we put it as a fraction, 2/5. Rewrite it, so x is equal to 2/5 over w. Now, you could rearrange that fraction if you wanted, but it doesn't really matter. Now we're on to step 3, which is where you actually answer the question. So step 3 is find the value of y when w is 2. So you see how, because we've got w, I'm obviously going to have to sub it into this second one, aren't I? That's the only one that has w. So we could work out what x is when w is 2. So we've got 2/5 divided by 2, basically, isn't it? That's 1/5. So x is 1/5, but obviously we want to know y. So I'm going to take my x as 1/5 and sub it then into the first equation, which does have x, and then it would give me y. So y is equal to 12 times 1/5 squared. So square your answer, times it by 12. Now you can either write it as 12 over 25, or 0.48. The decimal's not too difficult, so I'll probably put that. 0.48. So it's just normal proportion, but you've had to do it twice, basically. And you get 5 marks. So question 15, the incomplete table and the incomplete histogram give information about the times taken by some students to run a race. So you can see we're missing obviously this box here, and then we've got the histogram here, which is missing basically some over here, isn't it? Let's actually see what the question is. So they've told us that none of these students had a time for the race such that the time would be less than 10 seconds. So there's nothing over here on the histogram, that's fine, that just needs to stay blank. Or the time is greater than 26. So we're missing between, well, it looks to be about 19 to 26, aren't we, on the actual histogram. So part A, use the histogram to complete the table, and then part B, use the table to complete the histogram. So let's have a look, see if we can see all of that. So they've said use the histogram to complete the table. For histograms, this is our formula: triangle, frequency at the top, frequency, density, and class width at the bottom. The way I remember that is because the ones with 2 letters go at the bottom. That's just how I kind of remember which way around it goes. We want to work out the frequency for the first bar, don't we? If we cross that out, do you see how that would be frequency density times class width? So the frequency density for this bar is there. We don't actually have a scale, so that's something to consider. And then, obviously, the class width we do know. So that one's frequency density times the class width, which is 2. Do you see how the width of that is 2? So we need to know a scale for the frequency density before we can work that out. So let's have a look at our actual histogram. We do have some pairs, don't we? And what I mean by that is where, let's say this one, this bar here, I obviously know the class width, but also I know the frequency. So do you see how that one I could use to work out the frequency density, and then we'd work out a scale from there? So you can see if I cross that out, frequency density is frequency divided by class width. So frequency density is frequency, so that would be 10, divided by class width, which you can see is 4, which is the same as saying 2.5. So you see how this is 2.5. Does that then help you work out a scale for the rest of it? So if we see how many squares we've got, of these squares of 5, you've got 1, 2, 3, 4, 5. So each of these is 0.5, isn't it? Like this is 1, that's 0.5, that's therefore 1.5, the one we wanted to know. That one's therefore 2, and so on. So I can use that to then come back here and say, right, I needed to do frequency density times by the class width. The frequency density for the first bar is 1.5. So you see how that's then obviously therefore 3. Okay, so that's part A. We've worked out the table. Now we need to put the rest of the bars here. Let's see. So from 19 to 26. So we've got 2 bars we need to do. Now we know our scale as well. What we need to do is work out the frequency density for both of these. So we said frequency density is frequency divided by class width. So for this one is 9 divided by class width is 2, isn't it? So that's 4.5. So if that was 2.5, that's 3, 3.5, 4, and then this is 4.5. So my bar is going to go up to here, isn't it? Pretty much for that one there. So let's get a ruler. It's from 19 to 21, so just be careful of the scale. 21, I think, is this one here. Looks like 2 squares for each one, doesn't it? And then up to 4.5. There. So that's that one. Then the second one, again, we need to know our frequency density. So that's 7 frequency divided by the class width, which is 5. You might want to know what that is a decimal. So let's get our calculator. 1.4. So 1.4, looking at this scale, obviously just check if the y-axis is a different scale to the x. Yeah, it looks like each 0.1 is just one square, isn't it? So it's one below that, 0.5, 1.5. Here, and then across to 26, which is two little squares along from 25. And obviously join that up. There, so you can do it straighter than I can. But there are our two other bars. Okay, so that's all of part A and part B. As you can see, complete the table, complete the histogram. There is a part C on the next page. So the histogram below gives information about the times taken by 43 students to run a different race. So this is completely different. Okay, we've moved on now. We need to work out an estimate for the median of the times taken by these 43 students to run the race. So median from a histogram basically is that question. So the median is the middle. So I want to know, first of all, which is the middle student. So because it's an odd number, what you can do, you can just half it as it is, but when it's an odd number, I tend to add 1 and then half it. So that'd be 44 divided by 2, which is 22. So that means I'm looking for student number 22. Okay, so I need to figure out in which of these bars does student number 22 fall. Obviously, it's normally one of the middle ones, but you need to know for certain. And what that means is I need to know the frequency of these bars, like how many students are in each of these bars, because obviously it's different to the previous table and the previous histogram. So bring your formula triangle back again. We're trying to work out frequency now. Frequency, as you can see if I cross that out, is frequency density times by the class width. So basically the two axes times together. So for the first one, the frequency density is 2, and the class width, let's just check the scale. It's the same scale as the previous one, so I would say that's 12. So that's 2 as a class width, isn't it? So that one would be 2 times 2, obviously 4. So there's 4 students in this one here between 10 and 12 seconds. Then we do the same for the next one, so obviously we need to get up to the point where we're including 22 students. That's only 4 students. The next one we've got frequency density again is 2, but then the class width is 4 because that's 16, isn't it there? 4. So you see how that would be 8 students here. Again, if I add that together, that's 12. That's still not enough, is it? So I'm going to have to do the next bar. Frequency density is 4 this time. The class width is also 4, which is 16. Now, if you added those together, 12, 18, 28, that's 28, isn't it? Do you see how that would be enough? Like, obviously, student number 22, if you were to line them up in order of their times, student number 22 would fall into this bar. So that's the first thing. You need to work out which bar do they fall into. Obviously, if you've got the table there, it's much easier. You can just count up the frequencies, but we didn't have that because this is different, a different histogram. So we know that student number 22, and therefore the median, is somewhere between 16 and 20. Now we need to kind of zoom in on that a bit more. We need to zero in on actually a number. And you're not just going to guess, right? We actually are going to estimate it properly. So this is where you need to go, well, how far into the bar is number 22? And I'm not looking at, 16 and 20, like, don't get mixed up with that because I know the numbers are kind of similar. It's not in terms, that's seconds, isn't it? The student number 22 is in terms of students. Okay? So looking at, we're effectively doing cumulative frequency here, really, aren't we? So I know that the first bar starts obviously at student number 1, ends at student number 4. The second bar starts at student number 5 and ends at student number 12 if you add the 8 on. Do you see how, therefore, we're starting from 12 onwards is then adding 16. 12 to 28 is this bar here, isn't it? So how far in is 22? It's kind of hard to explain. 22 minus the 12 other students. See how that's 12? That's 12, isn't it? So I'm doing 22 minus the students in the previous bars, which gives me 10. So it's 10 students into the third bar. And then out of how many students are in that bar? 16. You see how I'm just trying to create like a proportion? Like what fraction of this bar is number 22? They would be 10 students into that bar out of all 16 students. Hopefully that bit makes sense, because I think that's the most complicated bit. And then because that's basically a proportion, isn't it? I just multiply that by the class width. So the width is 4, isn't it? 16 to 20. Times that by 4, so let's get our calculator. 10 over 16, or 5 over 8, I guess. Times 4 gives us 5 over 2, which actually, let's get it as a decimal, 2.5. Now we're almost there, okay? This is almost at the last bit. You just scroll down, see it? So that represents now in terms of the x-axis, which is seconds. Now, obviously the median isn't 2.5 seconds because that would be like over here, wouldn't it? No one's taken 2.5 seconds. What that is 2.5 seconds into that third bar. So do you see how the starting point of the bar is 16? So it's already 16 seconds plus the other 2.5. So you need to add whatever the starting value of that bar is. So your actual median is 18.5. We said it had to be somewhere between 16 and 20, didn't it? Which is. Okay. So, yeah, it's a little bit complicated to kind of explain. There's just a lot going on. And are we talking about students? Are we talking about seconds? Are we talking about, frequency density? It's a lot to take in, that one. Okay, question 16. ABCD is a trapezium. AD is parallel to BC. You can see with these little arrows, that means parallel. Calculate the area of triangle BCD to one decimal place. So I'm looking at this. I know they've said it's a trapezium, but if you just kind of ignore that for a second, it's two triangles, isn't it? Two scalene triangles. And they've given us some angles, they've given us some sides. So that's normally trigonometry, but more specifically, it's not SOHCAHTOA because it's not a right angle. It's therefore sine rule, cosine rule, or obviously the area of a triangle, but that trigonometric formula. So that's what I'm thinking of. When you look at your formula sheet, all of those are on there. So obviously they've asked me for the area of the second triangle, this one here. But currently we've only got one piece of information about it. And normally area of a triangle is half base times height, or base times height over 2. The thing is that that's the perpendicular height, which we don't have. So I already know that I'm going to be using the trig version, which is half AB sine C. And that tells me I need to know two sides and an angle. Do you see how currently I've only got one side? So I'm already missing two pieces of information. So that's why we've obviously got the first triangle there. So they've also mentioned that they're parallel for a reason. So I kind of started there and went, well, being parallel lines, what can I use from the first triangle in terms of angles that would then tell me something about the second triangle? And my first thought was the 42. This is like a Z shape, isn't it? This here, if I try and highlight it more or less. Oh, that's a Z shape, isn't it? So that's alternate angles, which means that angle B, this one here, is also 42. So that's what the parallel lines are telling me. Okay, so now I've got one side and one angle. Do you see how I'm still missing another side? And it has to be, I need to have the two sides that surround the angle, so I need to know dB. Hence why I've also been given 7.9 and 112. So looking at the top triangle, how can I work out dB? If I put X here for now, how can I work that one out? It's either going to be sine or cosine rule, isn't it? You just have to figure out, based on the information you've got, which of those two formulas it fits into. So sine rule is normally two pairs, so two angles, two sides. And cosine rule is three sides, one angle. Here, we've got two sides, two angles, haven't we? And luckily, they are actually opposite. You have to make sure that they are pairs, as in, do you see how the one that I want is opposite an angle that I do know? And the other side I know is opposite another angle I know. So that's two pairs. So we're going to use sine rule first to find out dB. If you're looking for a side, put that at the top of the fraction. So let's say we'll call it, well, let's call it dB, just so we know which one we're talking about. dB over sine of the angle, which is 112, that's the one opposite, is equal to, and then you do obviously the other side, 7.9, to put both sides at the top or both angles, depending which one you're looking for, of the angle opposite that one, which was 42. Now, because I want to find dB, I just need to rearrange this to solve for dB. And that just includes multiplying by sine 112, doesn't it? So dB, in my calculator, I'm going to put 7.9 over sine 42 multiplied by the other sign, just to get it across on the other side of the equation. So that's what's going in my calculator, okay? Sine 112 multiplied by sine, I'm going to click on it. Oh, no, make sure you get in the right place. That one's 42. Let's start again. 7.9 over sine 42. Make sure you get them in the right places. Multiplied by sine 112. There we go. Obviously, you're going to get loads of decimals. You can just write down a couple of them, but try and keep this answer in your calculator because we're not actually done with the question yet. So 10.946 ... So that's now dB, isn't it? .946 ... Now do you see how, because we wanted to work out the area, didn't we? Half AB sine C, we've got the information. So if you need to change the labels, feel free to do that so it matches your actual equation, your formula. So this angle has to be C because that's the only one I've got, isn't it? Therefore, I mean, you could just put this as like A and B. It has to be the sides that surround the angle, doesn't it? So now all I need to do is the area is half times 10.946, which I will just copy my answer from my calculator on the actual thing, multiplied by 15.3, multiplied by sine of the angle 42. That's what we're typing in now. So you see how I've still got my answer there. You can go straight into a half times, and then instead of putting just 10.946, because that's cutting off the decimals, isn't it? I'm going to put the answer, and then the 15.3, and then obviously sine 42. So I get 56.034 ... Now they've told me to round it to one decimal place. So do you see how that would be 56.0? You actually do have to write the 0. I know it seems kind of pointless, but you do have to write the 0 because they've asked for one decimal place. So even if it is 0, you still need to write it. There we go. Question 17, we've got iteration. So first of all, show that the equation x cubed plus 2x minus 6 equals 0 has a solution between x is 1 and x is 2. So this one you just have to memorize what to do. Basically, it's the same every time. If they give you this question, you first have to substitute in both numbers. So as in, when x is 1, obviously separately I mean, 1 cubed plus 2 times 1 minus 6, and you work out what that equals to, it's not 0. So that's 1 plus 2, which is 3, minus 6, which is minus 3. Then do the same with the other number. X is 2. We get 2 cubed, which is 8, plus 2 times 2, so plus 4, which is 12, minus 6, which is positive 6. Now you should end up with two numbers. If this is 0, you should end up with one number that's negative, one that's positive. It doesn't really matter what the numbers are as long as one's negative, one's positive. And then all you have to do is to kind of wrap it up and show that there's a solution is you just have to kind of write a statement. So I normally just say sign change, as in one's negative, one's positive, or it was negative in this case and then it became positive, didn't it? and you put therefore, and then you just literally copy this bit. Literally just copy solution between x is 1, obviously just match it to your actual question if the numbers are different, and x is 2. That would be your 2 marks. You just have to memorize to do that, literally. Just have to memorize it, okay? B, show that the equation x cubed plus 2x minus 6 equals 0 can be rearranged to give this. So you have to kind of look at both of them and meet yourself in the middle, try and figure out, because normally they've rearranged it in a way that you wouldn't necessarily feel is natural. You've got to try and figure out what they've done. So what it looks like here is, I think what they've done is, well, first of all, they've moved the 6 across. That's kind of the most obvious thing, isn't it? X cubed plus 2x equals 6, because the 6 is, first of all, on the other side, but also now positive. And then they divided by x squared plus 2. You have to figure out where that's come from. And they've obviously therefore left an x there. So they've obviously factorized it, which I think is something that's not necessarily natural to do, but do consider that as a possibility. They've obviously factorized it and then divided by that bracket. Squared plus 2, and you just get to what they've got. That's 1 mark. And then part C is the actual bit that relates more so obviously to iterative process. Starting with x0 is 1.5, so that's your starting number. This is basically an estimate for their solution, right? You know how they originally said it's between 1 and 2? They're just starting with this number and kind of as an estimate. Use the iteration formula. This bit I think people find hard to understand what it means because there's kind of a lot of letters and numbers and things going on. It's kind of like a sequence, really, because it's saying, this is saying to get the next number, to get n plus 1, so to get the next one, I need to do 6 divided by the previous one squared plus 2. Okay, now you just have to memorize what to do in your calculator. Obviously the formula is different every time, but the logic is the same. So we need to use this formula twice. I feel like normally it's 3 times, so just double check how many times they want you to do it. Twice to find an estimate for the solution of that equation. So they've said start with x0, so therefore I need to work out x1, because that's the next one, isn't it? And then x2. See how that's twice? I need to know those 2 values. So what I need to do is 6 divided by the previous one. See how the previous one to x1 is x0? So that'd be 1.45, and you square that and then you add 2. Now there's an easy way to put it in the calculator. What you have to do is type in the starting number first, so 1.45, press equals to see how that's now your answer. Okay, it's now kind of in the memory as the answer. Get rid of that and then you type in your formula. So in this case it's 6 over, where it says xn, that's where you put your answer button. And then obviously in this case we're going to square it, and then in this case we're also going to add 2. That's what you're going to get. Now because I already inputted my answer as 1.45, if I press equals, it's now giving me the next number, hasn't it? Now I tend to just write down all those digits personally. That's just what I do. Just write down kind of as many digits as you can. So that was x1 is 1.4625,228. What was the last 2? 52. Just write down that many, to be honest, might as well. And then for x2, do you see how you don't actually have to write this out, but just so you can see, it would be 6 over and then it would be all of this. That's why I'm saying you don't have to write it out. I normally write out the first one just so they can see the working, but it's technically ... all of that squared plus 2. Like it's always the previous answer that you add in for the next one. So all I need to do in this case though is press equals because I've got the answer there. And then the next one is 1.4496 ... So I'm going to write that down. 1.449634,937 ... Yep. Now in this case, because they've said they want us to get an answer, find an estimate, a singular answer, it's always that last one. So in this case it was x2 because they only asked for it twice, but they have said to round it to 4 decimal places, so that'll be there, wouldn't it? And the next one is 3, so we don't need to round up, we can just leave it as 1.4496. Okay, so always take the final one, whether that's the second time or the third time that you've done it. Okay, that should be a really easy 6 marks, to be honest. You just have to memorize kind of what to do for those different questions. Question 18. A, B, C, D is a quadrilateral. E, F, G, and H are the midpoints of AB, BC, CD, and DA. Then they've given us some vectors, so I'm going to label this. So A to H in that direction is A to E is B, D to G, where's that here, is C. Prove using vectors that E, F, G, H is a parallelogram. So first of all, I'm going to draw that, E, F, G, H. You can always draw anything on the diagrams if that's helpful to you. Feel free to annotate kind of the question however you want to, really. Roughly. So, proving that it's a parallelogram is basically we need to prove that the opposite sides are parallel to each other, don't we? We need to prove that this is parallel to this. It kind of looks the same as the vectors there, but the arrows mean parallel, don't they, normally? And that this one is parallel to this one. So, to prove that they're parallel, we just need to find out vectors for those in the first place. So I need to know EF, FG, GH, HE, so on. So starting with EF, what I would do is I would come from E to B and then down to F. But then you're thinking, well, I don't know what those two are. Well, yeah, we do, because if that's the midpoint, all of these are the midpoints, technically this side is also B, isn't it? It's the same length, it's a midpoint, as AE, but it's also obviously on the same line, so it's the same thing. So that's B. In the same vein, this one here is also A, this one here is also C. Now the only thing we're missing is BF, which is the halfway from BC. So we also need to work out BC just separately to that, don't we? So BC, you'd obviously start at B, come down here, along here, and up here, wouldn't you? You'd have to follow the lines where you actually got defined vectors. Now, first of all, we're going the incorrect direction, so it's a minus. That would be minus 2b, and then along here would be plus 2a and plus 2c. So that's the whole of BC. But I only want to know BF, which is half, isn't it? It's the midpoint, it's half of that. So B to F, I can just half, or like divide this whole previous one by 2. Same symbols, but instead of being 2b, it's just minus 1b plus 1a plus 1c. Okay? So that's minus b plus a plus c. Alright. It's not going to let me write out the whole thing. Pick it up. There we go, that's better. Okay, so we're focusing, let's say we start with EF. That's a bit clearer now, isn't it? Because all of them are defined. EF would be B in the correct direction, and then minus B plus A plus C, because again, that's the correct direction. You would simplify that to see how the B's would cancel, you get A plus C. Now, the one that's parallel to that is HG. Make sure you go in the same direction as well, so that the symbols are the same. H to G. I could go, do you see how on that one it's a bit easier? I could go A plus C directly, just down to D and up here, A plus C. Now you can kind of see what's going on. This is the same as this. When two vectors are parallel, they might not be the same size, that's fine, but they're multiples of each other, aren't they? As in, the coefficients of A and whatever the other letter is, A and C in this case, are multiplied by the same scale. Now in this case, it's just 1, isn't it? They're the same size as well. So I can write EF, in this case, is not even a multiple, it's just the exact same thing. Not only is it parallel, it's the same size as well, is equal to HG. Now hold on for that, because we also need to prove that the other two are parallel. I don't know if you can still see that. EH and FG. I just about see that. Move it down a bit again. So EH is, you see how it's minus B because I'm going the wrong way? Down that line there, plus A. And then the one that's parallel, or should be parallel at least, is FG. That one, we need to go to C. So this one is also the same as the minus B plus A plus C, isn't it? So that one you've got minus B plus A plus C, and then do you see how that's minus C because I'm going the wrong way? So if I simplify that, that's minus B plus A, and the C's cancel. And now these two are the same. So again, not only are they multiples of each other, they are literally just equal to the same size. So you can therefore write, and maybe let's write it down here. EF is the same as HG, and EH, so the opposite sides of that quadrilateral we've created are literally the same vectors, which therefore means that they are parallel. They're parallel. That one's also parallel, isn't it? And if you've got four sides where the opposite two sides, the pairs of them are parallel to each other, you can say that therefore again, what was it? EFGH is a parallelogram. You don't have to explain why, it's kind of just, this is the explanation as to why, okay? You don't need to write in words. Parallelogram. You just have to kind of put a little summary there of what you were trying to prove. Okay, you're proving that they are just generally multiples of each other. In this case, the multiple is just, the scale factor is 1, isn't it? So they are literally the same as each other. Therefore, they're parallel. And because there's two pairs of them, therefore it's a parallelogram overall. Okay. All right, question 19. We've got functions now. This is actually quite a nice one, considering we're almost at the end. So functions f and g are such that f of x is 2x plus 3 all squared, and g of x is 2x minus 1. First of all, find g of f of minus 3. So this is a composite function. So you just have to remember which way around it goes. It's always backwards, as in we're going to sub f into g. Now, you've got two ways of doing this. You could work out the composite function g of x and then sub in minus 3 at the end. Or, it's a little bit easier, what I tend to do is I sub in minus 3 first. So minus 3 into the f. So f of minus 3 is 2 times minus 3 plus 3 and then squared. I would literally work that out as a value. So 2 times minus 3 is minus 6, plus 3 is minus 3. Minus 3 squared is positive 9. And then that answer, you can then sub into g. I find that a bit easier. Obviously, if they just ask for the composite function without, if that's just x, you'd obviously just have to take the whole of this and sub it straight in, okay? But if you've got a number, it's a little bit easier. So 2 times 9 is obviously 18, minus 1 is 17. Literally, that's the answer to part A, 17. Now, part B, though, see, yeah, I'm going to leave that there so you can see the functions, is finding the inverse function of g. There's no numbers here. So the inverse function, I normally say swap, in this case g of x, for y, just for now, is 2x minus 1. Invert it, so as in change the subject. Some people like to swap x and y now and then change the subject. I tend to just change the subject straight away and then swap it at the end. It doesn't matter, whatever you prefer. So I'm obviously going to add 1, and then you see I'd have to divide by 2. Then x is then the subject. Now obviously we don't actually want y though, do we? There's no y's involved here. I've just put it there so it's easier than the g of x. So I swap it at the end, as in where it says y, I'm actually going to put the x back there. If you swapped it at the beginning, you obviously wouldn't have to swap at the end. So that's just a personal choice. So the inverse function is x plus 1 over 2. Now, just to note, if you do get a number here, because sometimes they give you a number, as you saw, I subbed in the number first and then did the composite thing for part A. When it's the inverse function, if you've got a number, you have to do the inverse first and then sub the number in at the end. So just be aware that the order is slightly different. Because if I subbed in a number, and then obviously I got just a single value, how would I then invert that? Do you know what I mean? I'd have to work out the inverse first, like this, and then sub in a number. If they're, you know, if they'd said like g to the minus 1 of 3 or something, I would sub in 3 at the end. Okay, that's literally it for the functions. That was quite a nice functions one. Question 20. we've only got 2 more, is obviously algebraic fractions, 4 marks this one. So we need to write all of this in the form ax plus b over cx plus d, where a, b, c and d are integers. It's basically just simplifying these and obviously doing the plus, doing the divide, all of that. So it's fine, it's just a lot of kind of pieces to work with. Now, when we simplify algebraic fractions, we have to factorize. So I try and factorize as much as I can at the start. So for example here, 3x minus 21, you see how that would simplify? I could factorize it into single brackets. Could be single or double, it just depends. In this case, obviously single. So I factorize that, leave that there. Nothing else I can do with that right now, is there? And then inside my square brackets, x plus 4, I can't do anything with it, but because I'm going to divide, I'm just going to make it into a fraction. If you want to make any number or any algebraic thing into a fraction, just put it over 1. So I'm just going to leave that there for now. Can't factorize it. And then here, I can't factorize the denominator so far, can I? Leave that there. But the numerator, see how the numerator is obviously a quadratic, a full quadratic, so I should be able to factorize that into double brackets. The other thing to consider though, do you see how you've got 2x squared, you've got 6x, you've got 56, they're all even numbers as in multiples of 2, aren't they? So what I could do is pull out 2 first, just because then it makes it easier to factorize into, oh, I didn't even pull out the 2 there. Pull out 2, make sure you actually do pull it out. Minus 56 divided by 2 is 28. And then you could, that's still obviously a full quadratic, you can then factorize that into double brackets. Okay, so I'm just going to write it here and then I'll replace it. So obviously it's x in both. And then we're multiplying to make a negative, so 1's plus, 1's minus. Factors of 28, so 2 numbers that multiply to make 28, that when you add them, obviously 1's plus, 1's minus, make minus 3. So 4 and 7 would work, wouldn't it? 4 times 7 is 28. Now we'd have to do minus 7 and then plus 4. That would make minus 3, wouldn't it? So I'm going to rub this out and just rewrite it, so I have to write the whole thing again. Okay, so that's 2 on the outside, x plus 4, x minus 7. Okay. There we go. We factorized everything. Now, I always check, can I cancel anything out so far? And actually I can't, so we'll leave it like that. Now I'm actually going to do the brackets in terms of the divide. So dividing fractions, don't even worry that it's algebraic, just think fractions generally. To divide them we do keep, flip, change, don't we? So keep the plus there, keep, flip, change. So keep the first one, that's why I wrote it as a fraction, just to keep it there as a fraction. Flip the second one and obviously change it to a multiply instead of divide. And when we multiply, I'm going to keep all the brackets. Don't expand the brackets again. Obviously, that would be the opposite process of what we've just done, isn't it? So don't expand anything. Just kind of stick them together. So we get 14. Obviously, that's still there. 14, 3, x minus 7. Plus, and then we get x plus 4. Like I'm multiplying them, but I am keeping them in brackets. I'm not literally going to expand. 2x plus 3, and then at the bottom, obviously 1 times that is just the same, isn't it? 2x plus 4. And kind of every step along the way, I see if I can simplify anything, as in kind of cancel any brackets out. Do you see how now I've got x plus 4 and x plus 4? Can cancel that out, just to, you know, try and make it all a lot smaller, a lot simpler before I move on to adding. So rewrite that, we get 14, 3, x minus 7 still there. Plus, then it's just 2x plus 3 over 2x minus 7. Now I'm going to add them. So again, think about just normal fractions. When I add fractions, they have to have the same denominator, don't they? They need to have a common denominator. I feel like it can be quite hard with algebraic fractions when there's algebra in the denominator to figure out what you mean by a common denominator. It's not just like a number, is it? Do you see here how they both already have x minus 7, x minus 7? They both got that. So what I really am focusing on is the 3 and the 2. What's common, or what's the lowest common multiple of 3 and 2, basically, which is 6. So the first fraction I need to multiply by just 2. so the numerator as well, because whenever you change the denominator, you have to change the numerator. So that would be 28 over 6, and then still just x minus 7, plus the second one, to make it 6, I'd have to times by 3. 3 times the 2x. That's 3. So the common denominator, or at least the most simplified common denominator, is 6 brackets x minus 7. Now, you might have just multiplied those two denominators together and ended up with this squared, which is also fine, but the problem is then you end up with this there, and then this there, and then you have to expand that, and you end up with a quadratic all over again. You have to simplify it all over again. So I try and find the lowest common multiple, not just any common multiple, but the lowest. Because they already had x minus 7 in common, I didn't need to change that. I didn't need to multiply them by x minus 7 at all. They both already had it, so the only difference was that making the 3 and 2 become a 6. So that's the bit I guess is quite tricky. That's why this is the second to last question, really. So I'm going to expand this here. So that would be 6x plus 9, wouldn't it? Let's just change that. Because they've got a common denominator, you can then just literally add them, can't you? So 6x, 9 plus 28 would be plus 37, wouldn't it? And in the denominator, I've got it currently factorised, but if I go back, do you see in the top, in the actual question they asked for it, there are no brackets, it's not factorised. So what I'm going to do is I am going to expand the denominator as well at this point. So that would be 6x minus 42. Now obviously you double check, can I simplify anything? What that means is, do we have a common factor between all 4 terms? So do we have a number that divides into all 4? No, we don't. So that is the most simplified, and that is the format they asked for. So that would be your answer. Okay, it's just a lot going on. It's kind of a lot of different things that you kind of know how to do separately, but they've put them all into one question. Okay, we're on to our last question now, question 21. This one's 4 marks as well. So, need to move this down a bit. Oh no, you can see it, that's fine. So Vicky has a collection of medals. The Venn diagram gives information about the number of medals in her collection, where, now this little squiggly kind of E shape means the universal set, as in the words literally universal set, and what that means is just the whole Venn diagram. Oh, back over. If I can highlight it. It just means the contents of the whole Venn diagram, including what's in the circles, what's outside. It just basically represents the whole Venn diagram. So in this case, what they're saying is the universal set, or the whole Venn diagram, is all of her medals, basically. All of her medals will go either in A, B, or both, or on the outside. Then, more specifically, we've got A, so the A bubble is just for English medals. The B bubble is just for gold medals, so obviously the overlap would be English and gold at the same time. And then on the outside is anything that's either not English and not gold, right? So Vicky's going to take at random a medal from her collection, given that the medal is gold. So given that, as in, given that the medal was gold. So gold was B, wasn't it? So given that we're just looking at this bubble here, not the whole Venn diagram anymore, given that we've already picked one that is gold, the probability that the medal is English is 2 out of 11. So if I get my highlighter again, English is obviously the overlap here, isn't it? So out of the fact that she has already picked a gold medal, the chance of it then also being English is 2 out of 11. So we need to set up an equation, basically, don't we? They've said work out the number of medals in Vicky's collection. We need to know what x is. We need to create an equation in order to solve it, in order to know what x is. So my equation is obviously with this 2/11. If they said to you, just kind of ignore that. If they said to you, given that she picked a gold medal, what's the probability that it is English? You would put x, or you should put, over the whole bubble, which would be 5x minus 3 plus the other x, wouldn't it? 'Cause that's also in B. That's, if you had numbers there, that's effectively what you would do if you had another question. Then that's therefore what is equal to this. That's where my equation comes from. Just translating that wording into actual equations. From here, once you've translated it, then it's fine. It's just solving equations, isn't it? So obviously I can add those. So that'll be 6x minus 3, wouldn't it? Now, because I've got fractions, I'm going to cross multiply. So what I mean by that is multiply by both denominators to move them across, get rid of the fractions. So the left side would be 11x, and the right side would be like 2 multiplied by the 6x minus 3. This is just a linear equation now, isn't it? So 11x, obviously expand. 12x minus 6. Now we're solving, so I'm going to move the 11 across to keep a positive number of x, so that would be just x, and if I add 6, x is 6. Okay, but don't forget though, because sometimes when you feel like you've solved it, you're like, oh yeah, that's the answer, I've worked out what x is. The actual question was work out the number of medals in Vicky's collection, i.e. the number of medals in the whole of the Venn diagram. So the whole of the Venn diagram, do you see, would be 7x minus 11, plus x in the middle, plus 5x minus 3. And don't forget, it also includes the 34 on the outside. That's the whole universal set. That is what we need to find out. Okay, that's the total, isn't it? Now, because I know what x is, do you see how I could sub that in? Now, let's just simplify it first. So 7x plus x is 8x, plus 5 is 13x. And then we have minus 11, minus 3, plus 34. So that's minus 14. So that would be what, plus 20? And then if we sub in 6, obviously you can put this in the calculator, but I think that's 78 plus 20, which is 98. Okay, so just double check. If you've got one where you're solving an equation, was the actual equation the actual question, or was it something else? So yeah, we worked out x, but we then had to go back and work out the total number. So 98 should be your answer. Again, as you can see, that is the end of the paper. So I will link later on in the description of this live all of the videos that I have on different topics on this paper. So if you want to go through kind of any of the topics in more detail, then I will link it obviously in the description of this live. You can go through those. If you want to see paper 1 of this series, so this is the November 2023, obviously higher tier. If you want to see paper 1, we've already done that live, that's uploaded onto my channel. If you want to go through paper 3, that will be tomorrow at the same time, 7 o'clock. So we will do that tomorrow. If you want to just revise anything else, obviously have a look at my channel, go through the higher tier playlist. If you want to look at the June 2023 papers, we did those last week, all 3 for higher tier, so those are also uploaded. You can have a look at the lives playlist. Have a look in the description, I've linked a load of things down, a load of resources. If you don't have the correct calculator yet, I've linked that below as well, so make sure you go and buy the correct calculator and be practicing with it in your revision leading up to the exams. Anything else, if you have any other questions, please leave them down below in the comments of this video.